it's visible to you. Can you see my screen? Please respond to me so I know that you are there. It's not like you just logged into the meeting and sleeping. Huh? I have checked. Okay, clear. Thank you, Said, for confirming and Mohammed for confirming. Okay, so just let me tell you, this is the class for calculus. And since like you are going to miss this, you already missed the class on campus because there were exams, the rooms were occupied. So I'm going to cover up the things here. So what I'm going to do here is, we already started with chapter 3. And I hope you did well in your midterm exam. So in chapter 3, what we started with just a quick recap. We started with the concept of double integral. I hope you remember multiple integral. We started double integral. There I explained you first how do we find the like for integral for the function of two variable with respect to one variable. This was in the basics. Like I also sent you the link for the video. Then we worked directly on solving the double integral. Okay, so what actually we were doing is like earlier in chapter 1, you studied only about the definite integral. Okay, 1.5. We discussed about definite integral 1.5. So what was it? It is integral a to b fx dx. And physically, if it is, suppose this is your curve y equal to fx, then this single integral, or we call it as line integral, gives you the area bounded by this curve. This is x equal to a and x equal to b. So we were using the single integral for that thing. Okay. Now, when we talk about the double integral, actually double integral, what we are doing, we are dealing with the function of two variables. This function should be positive. It is defined over the rectangle where x varies from a to b, y varies from c to d. So you can see the limits for x. See, this is for x equal to a, x equal to b. This is y equal to c, y equal to d. So this forms this rectangle, which is your R. Okay. Then by evaluating this double integral over the region R of this function fxy is nothing but we are trying to find this volume. Okay. The z equals to fxy is nothing but the plane. Okay. So this is the volume that we evaluated so far in 3.1 and 3.2. So we evaluated, you remember 3.1, we studied a to b, c to d, fxy, dy, dx. So this is what we evaluated and we discussed in 3.1 and 3.2. In 3.1, a and b were a, b, c, d, all were numbers, the constant. But in 3.2, we discussed these things about the regular region. So instead of rectangle, it will be some region. Okay. Now, what we are going to do today is to discuss the next topic, which is 3.3, like changing the order of integration with the constant limits. So for that, first you need to understand what do we mean by the order of integration. So if you remember, when we write double integral fxy dx dy, and suppose here the numbers are a, b, and here c and d. So keeping the function in the middle, if you move towards the right side, say this is 1, this is 2. So you start integrating first with respect to x, and the second you are integrating with respect to y. Okay, remember, because how we are evaluating, we are solving this, the value of this integral first. Integral a to b f x y dx. And whatever answer we are getting, we are integrating it with respect to y. Okay, so here the order of integration. This is the order of integration. Like first we evaluate with respect to x and then with respect to y. So what we are going to discuss in this topic 3.3 is we are going to change the order of integration. So again, we will study this change of order of integration when the limits are constant, and in 3.4 it will be about when the limits are variable. Okay, so let's consider question. So here you have so what we are going to do, we'll see this how to do it with the help of example. The question will be like evaluate the integral by changing the order of integration. You have to change the order of integration. So to change the order of integration, first you need to know what is the order of integration here. So as I said, what you will do, you start with the function. This is your integrand that you are integrating. Okay. Moving on the right side, this is 1 and 2. So here also, if you remember, like moving this side and you move outside like this. So this is 1, this is 2. So it means these are the limits for y, outside are the limits for x. So here, the order of integration is dy dx. dy dx. It means first integrate with respect to y, and after that second time integrate with respect to x. Okay, this is the order of integration. And if we talk about the limits, what are the limits? We are integrating with respect to y. So dy goes to this one and dx is for the outer one. Okay, so the limits for x and limits for y. For x varies from -5 to x equal to 4. And limits for y are y equal to 0 to y equal to 3. Okay. Now, what they have asked here, evaluate by changing the order of integration. So this is your given order of integration. Now you have to change the order of integration. So as the limits, if you see all the limits here, -5, 0, 4, 3, all are constants. So you can simply change the order of integration. So changed order of integration will be so given was dy dx, so it should be dx dy. It means the first you should integrate with respect to x, and second time you should integrate with respect to y. Okay, so what will happen? Let's see. You will write your integral, your question. Let me. Okay, so you'll write double integral 2x minus 4y cube. Now what you want to write? Dx dy, this order of integration. So what it means, if it is dx dy, so here in the first integral, you should have limits for x. And what are the limits for x? -5 to 4. X is from -5, x equal to 4. Okay. And the outer one, should be for y. And what are the limits for y? Y equal to 0 to y equal to 3. So this is how your question get changed. Is this clear? Is this clear? Any question? Okay, clear. Thank you. Okay, so what we will do now? We have to evaluate this integral. So let me write this question over here. Double integral 2x minus, what is it? 4y cube. We are doing now dx dy. The value of x is from minus y 5 to 4. And limits for y is from 0 to 3. So in the constants, actually, when we change the order of integration, it will not change the value of integral. So either you solve this dx dy, or you solve the integral with dy dx, you end up with the same answer. Okay? Okay, so when you are evaluating, what we will do? We will solve this integral. So let's write it down. Minus 5 to 4 to x minus 4y cube dy. Sorry, dx. So can you tell me we are integrating with respect to which variable and which variable to keep constant? You did this in exam yesterday. You can unmute yourself and say the answer. Because of dx, you integrate with respect to x and the constant will be. So here you see no x term. So what will be the integral? Integral will be 2 integration of x square over 2 minus 4y cube 4y cube, and then there is no x, so what you will do? You multiply by x and then substitute the limits. Limits are for x. X is from minus 5, x is equal to 4. So you have to replace these two x first time by 4 and then by minus 5. So what you can do, you can still cancel this. So this gives you 4 square minus 4 y cube into 4 minus of minus 5 power 2 minus 4 y cube into minus 5. Okay. It's okay if you don't write. Please focus on understanding this because I'm going to share these slides with you in the chat. Okay. So when you solve it, it gives you 16 minus 16y cube minus of this is 25 plus 5 times 4, 20y cube. When you simplify this further, what you will get? 16 minus 25. How much it is? Minus 9. And minus 16 minus 20 gives you minus 36 y cube. Okay. So this is the value of this integral. And so now the question is similar to what you did in 3.1. Okay. So then we solve this 0 to 3 minus 9 minus 36 y power 3 dy. Okay, so you can check your answer that there is no x term. So it means what you did is correct. Now it becomes a simple definite integral. You get minus 9y minus 36y power 4 over 4. And the limit for y is from 0 to 3. You can simplify 4, get 9. So you have minus 9y minus 9y power 4. Y is from 0 to 3, giving you minus 9 when you substitute the limit. 3 power 4. And this will be 0. So you have this at y equal to 3 and this is at y equal to 0. Then you simplify to get your final answer. Minus 27 and then minus 9 times 81. Okay, and simplify, you will get your final answer. Okay, is this clear? So basically what you have to do is, you have your question like dy dx. When it's a constant limit, simply change the limits dx dy and change the value of this integral. Okay, let's do this. Again here, you have dx dy. So what you are going to do, you have to change the order of integration. So it means you will be writing e power 2x minus y. You have to write dy dx, changing the order of integration. Now we have to work for the limits. So if you see here, these are the limits for x and these are the limits for y. So when you are writing dy, it means here you should write the limit for y and here you should write the limit for x. So your question becomes integral limits for x is from 0 to ln 5, integral 0 to limits for y, which is 0 to ln of 2, e power 2x minus y dx dy. Or in short, if you want to, like, you need further shortcut, but this will work only when the limits are constant. Like you just shuffle the position of these two and then shuffle these two integral. Okay, and you will get it. And then the process remains same. Solving this integral first with respect to x, whatever answer you get, integrate it with respect to y. Okay, so this is a straightforward topic. That's not very difficult. So let's see another example. Again with constant limits. See why we are using the method of changing of order of integration, because it makes your integral easy. Okay. Now I want from you to tell me what will be the order of integration here. Like if I have y sine of x, what shall I write here? Come on, unmute your mic and speak. How do I know if you are awake or you are sleeping? Hmm?
Changing the order of dy and dx first.
Correct. Thank you. At least someone responded. It's not like I'm teaching to my screen. Okay. So it is dx, dy. Good.
Secondly,
So what? What
secondly,
shall I? Yeah.
yes, it's ny on the integral.
Mhm. So here for first integral, what shall I write here?
0.
0 to pi. Good. And here 1 to 2. So you can use the shortcut that I explained for the constant limits only. Change dx dy and change this integral. Good. Thank you for confirming. Thank you for answering. So see what happened here. If you were integrating it with respect to y first, you have y here and you have y here. So you will be using integration by parts. But now, when you change the order of integration, what happened? You will be integrating this portion. Sorry, I missed something. Wait a minute. It's xy. So you will be integrating this integral. Let me write it down. So this is integral 1 to 2 y sine of xy dx. Here, I'm integrating with respect to x, treating y as a constant. So the only function of x that I have is this. I don't have anything in product. So I can do it directly without using integration by parts. So what I want now is what will be the integral of sine of xy. So for this, actually it's better if you use this rule. Sine of ax plus b dx. I hope you remember I gave you this rules before quiz 1, even before midterm. Integral of sine is cosine ax plus b divided by a plus c. So what we were doing here, as a is a constant, and this constant is multiplied with x. So we divided by a. So in the same way, if I have to integrate sine of xy with respect to x. So can you tell me, if I write it as cos of xy, I should divide by which term?
Divided by x.
Divided by x. Correct. Because, see, you are integrating with respect to x. Y is a constant. So y is, in other words, is a coefficient of x. So you have to divide by, sorry, not with x, with y. Is it clear?
Yes, it's by y.
It should be by y. I don't know what happened to other class. You are tired, I understand, but this is next time. Can we take our class on Wednesday in morning? If it's okay with all of you, because afternoon I feel you are tired, or maybe later in the evening, say around 4, if it is okay with all of you, because we have to take one more class. Okay, we'll talk about it later. So let's do this here. So this integral will be, now y being the constant, you can take it outside. So y will be same. Integration of sine will be minus cosine of xy divided by y. And the limits are, these are the limits for x. X goes from 1 to 2. Okay, there is a multiplication sign in between. Okay, so can I cancel this y with this y?
Absolutely.
So you get your answer as minus cosine of xy. X is from 1 to 2. Substituting the limits gives you minus cosine of 2y minus cosine of 1y. Okay, simplifying this gives you minus cosine of 2y plus cosine of y. Now we will solve the other integral, that is integral 1 to 2. Means we'll substitute, sorry, not 1 to 2, 0 to pi. 0 to pi minus cosine of 2y plus cosine of y dy. Okay, so now it is a definite integral. Integration of cosine is sine. Just 1 minute. Okay, sorry, I got a call in between. Sorry for that. Okay, so when we integrate this, integration of cosine is sine 2y, and in the same way, the coefficient of y is 2. So you divided it by 2. And then here it's simply sine of y. The limits are for y from 0 to pi. So after that, you just substitute here like sine of 2 pi over 2 plus sine of pi minus, you get here sine of 0 over 2 plus sine of 0. Okay, these are the limits at y equal to pi, and these are the limits at y equal to 0. So if you calculate it by using calculator, you will find that this is 0 because sine of 0 is 0, sine of pi is also 0, sine of 2 pi is also 0. It is because you have a result that sine of n pi, when n is an integer, is always 0 and belongs to integers, is 0. Okay? Otherwise, you can use the calculator to get the answer. Is this clear? So when it is like changing the order of integration with constant limits, you don't have many things to do. You simply change the order and change the limit and it works here. But this is not the case when you change the order of integration for the variable limits. Okay, for that you need to plot the graph to find the new limits. So for instance, if you have this like with variable limit, this is in 3.4. So here the thing is that here the order of integration is dx dy. Okay, these are the limits for x, these are the limits for y. Y varies from 0 to 1, x varies from y to root 1. In this case, you cannot simply write it as double integral dy dx, and here you write 0 to 1 and y to root of y. Okay, this will be wrong. You cannot do this because it involves variable limits. Because, see, first of all, what will happen here is when you evaluated these integrals so far, what you are getting the final answer as a number, okay? But in this case, when you evaluate, you will get the final answer in terms of a variable, which is not possible. For instance, see, understand this. If you have y, root y, 0 to 1, dy dx. So when you evaluate this, so what you will have integral, you will be solving integral 0 to 1 dy, which gives you y, limits from 0 to 1, that is 1. So this gives you y to root y 1 dx. Now what you see here, you are integrating with respect to x and your limits are in terms of y. This variable y is appearing again, so which is wrong. So this thing is not possible. So how do we work when the limits of integration are variable? So as I said before, you have to draw the figure. So you will be drawing some figure like this. So what we will be doing here is, like here the order of integration is dx dy. The limits for x is from y, x equal to root y, and the limits for y is from 0 to y equal to 1. So what we have to do is we have to plot all these curves. X equal to y, x equal to root y equal to 0, and y equal to 1. So this is your y equal to 0. This is y equal to 1 because this we are considering as y-axis and this is x-axis. This line is x equal to y and this curve is x equal to root y. So when we are doing integration dx dy, the order is dx dy. It means you are moving horizontal first, means x varying from y to this. So a point on this curve to a point on this curve. Okay, so when we change the order, it means we need dy dx. This is horizontal, changing it to vertical. So we have to move vertically. So vertically, whenever we move from down to up. Horizontally, left to right, down to up. So we have to find the value of y at this point to the value of y at this point. Okay. And what important thing we need? We need the point of intersection. Okay. So let's see step by step how to work on this question. So please pay attention to this because this is important. Okay. So here you see the order of integration dy dx. Order is dy dx. Okay. And the limits. Can anyone tell me what are the limits for x and what are the limits for y? Like as x is varying from which number to which number? You can even type in the chat. How you will do math? Y, this, and this. Yes? No answer? I have 25 students and no answer. I mean, X, if my question is clear. I want to know, like in this question, I said X is varying from X equal to Y to X equal to root Y, and Y varies from 0 to 1. So I need this thing for this question. Hmm. What do you mean by double, Ahmed? X is what and Y is what? See here, when I write like this, dx dy. So how do I know what are the limits for x dx? Means these are the limits for x equal to y to root 1. When I say dy, means outer one. So these are the limits for y, correct? I explained this here, dx, dy. So this is your question. So can you tell me now it is dy dx. So what are the limits for y? This inner integral. Y varies from 0 to y equal to x. Okay, good. I got the answer now. These are the limits for x. X varies from 0 to x equal to 2. Okay, now we want to change the order. So in changed order of integration, we will be writing dx, dy. So what we need here, we need the limits for x and for y. So it means we are looking for x varies from which number to x equal to what, and y varies from which number to y equal to what. Now as you see here, you are having here, you have 0, 2, 0 and x variable. So you cannot simply change it. For this, you need to draw. It is must to draw this. So what you will be drawing? You will be drawing this curve x equal to 0, x equal to 2, y equal to 0, and y equal to x. So 1, 2, and 3 as is direct. For 4, you need a table. Like for 4, which is y equal to x. Let me prepare a table to get the values of x and y. X, y. So when I substitute x 0, I get the value of y as 0. If I change here x to 1, I'll get the value of y as 1. And similarly, x is 2, y is 2. Okay. So here the points will be 0, 0, 1, 1, 2, 2. We need these points to plot y equal to x. So let's plot this. So this is your x-axis and y-axis, x-axis, y-axis. Let's put the point 1, 2, 3 on x-axis and similarly on y-axis 1, 2, 3. Okay. So first of all, we plot this 0, 0, 1, 1, 2, 2. So this is the point where x is 0, y is 0. This is the point where x is 1, y is 1. And this is the point where x and y both equal to 2. I hope you know how to draw this, how to plot a line. So when you draw this, you will join these 3 points to get the line. Okay, let me use this one. Sorry, this one is creating. I think I can move this ruler. So this will be how you will be drawing the line. Let's see if it works. Okay. So this is the line. Yeah, it worked. This is the line. Y equal to X. Okay. It's supposed to be here. Okay. This is the line Y equal to X. Then what you have? X equal to 0. X equal to 0 is nothing but the y-axis. This is x equal to 0. Y equal to 0. Y equal to 0 is nothing but the x-axis. Then you have x equal to 2. This is the point where x is equal to 2. So you have to draw a straight line. So it should be a straight line as my graph is like this. Okay, so this is your graph. This is your x is equal to 2. So your area is nothing but this one, this area. The interior only. Is this clear to everyone? The steps, what we did? Okay, good. I think it's only Ahmed who is here because he is the only one who is responding in the chat. Okay. I'll see when we will meet in the class how many of you remember this. Okay, so now what is happening here? When your order of integration is dy dx, it means dy means you are moving horizontally. Okay, so it means currently in the given question you are moving, sorry, not horizontally, vertically from down to up. Because here y equal to 0 and here y equal to x. Now, when we ask you to change the order of integration, it means you have to move like you were moving vertically. Now you have to move horizontally within this area because x varies horizontally. Okay. So before I go there, can you tell me what is this point? Here the value of x is 2 and the value of y is 2. So this point is 2, 2. This point is necessary. Okay. So we have to change the limit of integration. See, this is what we are looking for. We have to answer this. We did all this thing for this only. Okay. So here, what is the value of x at this on this line? On this line, the equation of this line is y equal to x. So can I say that x is equal to y on this line? And on this line, the value of x is 2. So we will say x is equal to 2. So the limits we get for x is x equal to y to x equal to 2. Now we have to look for the limits for y. So for that, check the extreme of this line. So this is the extreme. So here, what is the value of y? Y is 0. And here, the value of y is 2. So we say that the limit for y is from 0 to 2. So Once we did this, our thing is done mostly. Like the changed order of integration will be fxy dx dy. Dx dy. And here the limits for x, which is from y to 2. And here the limits for y, which is from 0 to 2. So see here the things are different. So this is how you have to work for changing the order of integration with variable limits. Okay, this is one part. And after that, you have to solve it. So let's consider this question. In this question, again, I have the same thing. You have to change the order of integration. So the current order of integration is dy dx. Here the limits are x varies from 0 to 2 and y varies from 0 to x. So to change the order of integration, what you have to do, you have to find the limits for x in terms of y. So again, you will be drawing the diagram similar to this. So you get this limits of integration because you see x is from 0 to 2. Here also x from 0 to 2. Y is from 0 to x. Y equal to 0 to x. So the changed order will be dx dy with the limits. Means you have to do everything that you did here and then you will be taking down these limits. X equal to y to x equal to 2. Here y equal to 0 to y equal to 2. So what happened? Your question. See this part, once you're done with this part, write down your question. Your question will be become now integral x plus y dx dy. Here the integration from y to 2 and is from 0 to 2. So when you start solving, it's now same like 3.2. Solve this integration, double integral with variable limits. So when you integrate y to 2 x plus y dx, here you are integrating with respect to x. Constant is y. So there is no x. So when you finish integration, what you will get? You will get integration for x is x square over 2 and y times x. Substituting the limits for y to 2. This gives you x square, that is 2 power 2 over 2 plus 2y minus y power 2 over 2 plus y times y. When you simplify it, you will get 2 plus 2y minus y square over 2 minus y square because y times y is y square. So on simplification, this gives you 2 plus 2y minus 3 by 2 y square. Or you can write 1.5. Both will be same. Now, other part 0 to 2, use this value. 2 plus 2y minus 3 by 2 y square dy. Now it became the question of 1.5, definite integral. So just integrate it. 2y plus 2y square over 2 minus 3 by 2 y power 3 over 3. And limits for y is from 0 to 2. So this 2 and 2 cancel. This 3 and 3 cancel. which on simplification gives you 2 times 2 plus 2 power 2 minus 2 power 3 over 2. This is when y is equal to 2. For lower limit, it will become 0. So you get 4 plus 4 minus, that is 4 as the final answer. Okay? Without changing the order of integration, if you try to answer this question, you will still get the same answer. Okay? But when in the question it is mentioned that by changing the order of integration, it is must that you change the order of integration. Okay? So remember the steps. Let's recall the steps. What you have to do? Whenever a question is given, identify the given order of integration and the limits for x and y. Then draw these limits to get the graph. From the graph, get the new limits of integration and then integrate. Okay? Is this clear?
Yes, clear.
Okay. Thank you. So let's do this thing also because see, the important thing is this slide. Once you know this, integrating this is easy. So this is the challenging thing. So let's integrate this question with the limits. Let's find out what will be the changed order of integration, okay, for this particular question. So if you see here, y. So these are the limits for, sorry, just 1 minute. Let's take this one. Oh, I missed something, sorry. Here it is dx dy. So if you look at it, these are the limits for x, that is x varies from 1 to x equal to root y. Okay, and these are the limits for y. Y equal to 1 to y is equal to 4. The current order of integration is dx dy. Means first you integrate with respect to x and second with respect to y. Now, what should be the changed order of integration? It should be dy dx. It means first you should integrate with respect to y and second you should integrate with respect to x. So to find the changed order of integration, you have to plot this. So these three are direct value, the straight lines, but for this you need to make a table. Okay, so if I say this as 1, 2, 3, and 4. So let's do for 2. X equal to root 1. So I prepare a table to get the points so that we can draw it. So if I write here x and here y. Okay, if y is 0, the value of x will be 0. If y is 1, we get the value of x as plus and minus 1, but we take only plus because all the region is in the first quadrant. Similarly, if I take the value of y as 4, then x will be, see, this is root of 1, this is root of 4. Square root of 4, again you will get plus and minus 2. We are considering only the first quadrant, so we use 2, positive 2. So the points on for this line will be 0, 0, because we always write points as x, comma, y. 1, 1, and 2, 4. Okay, 3 points are sufficient to draw any graph. So what we will do again is we will use the scale to draw the x-axis and y-axis. We just leave it. Let me draw it simply. Say this is x, this is y. Okay, let me keep the points as the we have y till 4. 1, 2, 3, 4. Say 1, 2, 3, 4. So the point 0, 0, this is the point. I'm plotting first this 0, 0, 1, 1. When x is 2, y is 4, it will be somewhere here. So note that this is not not a straight line, but it is a parabola instead. So when you draw it, it should be something like this. Okay, it should go through the points. Okay, so this is important. So please pay attention. This is your curve x equal to root 1. Next is y equal to 1. This is the point where y is 1. So this is your straight line, y equal to 1. X equal to 1. This is the point where x is equal to 1. So it should be a straight line like this. Next is y equal to 4. This is the place where y is equal to 4. So what is the region? You need a region like y equal to 1 to y equal to 4, x equal to 1. This is the place where x is equal to 1. So your region will be this. This is important to identify what is the region. And you should know these points. This point is 1, comma 1. This point is 2, comma 4 from this table. See, this is O, A, B. This is O, this is A, this is B. You need to find this point. This point is y equal to 4 and x equal to 1. So this is 1, 4. This is your region. Now here, you have the limits in terms of x first. Like you are first integrating with respect to x. Correct? You are first integrating with respect to x. It means you are moving horizontally. You want the change integration, change order means you need the integration first with respect to y. It means you have to move vertically in the change. So currently you are having it from here to here. Okay, this is for x. That is x equal to 1, x equal to root y. Now what you want in the changed order of integration is move horizontally. When you move horizontally, you move from this curve to this line. So you need the value of y on this curve. If x is equal to root y, can I say x power 2 is y? So the value of y is x power 2. And here, this is the line y equal to 4. So in the changed order of integration, the limits for y will be from x square to y equal to 4. Now, when we talk about the limits for x, what will happen? X is varying from where to where. This is your order of integration. So you have to look for the straight line. At this point, what is the value of x? 1. At this point, what is the value of x? 2. So x varies from 1 to x equal to 2. Okay, so the changed order of integration will be double integral fxy dy dx. First, now y, so the limits of y first, that is from x square to 4. And secondly, the limits of x, 1 to 2. Okay, this is your changed order of integration. If you understand this, then it's good because after that, nothing left. You just need to integrate. This is most important thing that you should understand. So if you didn't get anything, please ask me. Silence means I assume it's clear, huh? Why I'm saying this is important? See, getting the points, drawing the graph to get the new limits. This is important step because what you will have the questions. Suppose this is your question. This is your question. These are the limits for x. These are limits of y. You have to change the order of integration. Okay. So what it means, you have to write it as x square plus y dy dx. Now, what are the changed limits? So to change the limits, you have to do all this process. Okay, to get the limits from here. Y equal to x square to 4. Y equal to x square to 4. And limits for x is from 1 to 2. So once you did this, but you have nothing left. This is a normal integration like how you did in 3.2. So integral x square to 4 x square plus y dy. Integrating it with respect to y. So it gives you x square y plus y square over 2. Limit of integration is x square to 4. Giving you what? X square times 4 plus 4 square over 2 minus x square times x square plus x square and square. This is at y equal to 4 and this is at y equal to x square. Simplifying this will give you 4x square plus 8 minus. This gives you x power 4. This gives you x power 4. So it gives you minus 3 by 2 x power 4. Now use this in the first integral. 1 to 2, 4x square plus 8 minus 3 by 2 x power 4 dx. Normal definite integral. So this is the important step. If you get this step correctly, everything goes correct. Okay, so it is now 4x power 3. I'm just completing it quickly because you know this how to do this. X power 5 over 5. And then Substitute the limits from 1 to 2 and then complete it, okay? So this is all about 3.4. So we finished today 3.3 and 3.4. 3.5 is for self-study, triple integral. Okay, so work on that. So this is all that I have from my side for today. If you have any questions, ask me. No questions, huh? I have so many students and no questions. Okay, good.
No, miss.
So let me,
It is clear.
really? Okay, good. So when we meet again in the class, the first thing I will do is I'll ask the questions based on this. One question in the changing the order of integration.